I'm Anil Kumar. We are discussing a particular example on exponential functions which will remind you of solving exponential equations and then take you to the next level of finding derivatives. In the previous video, we solved part A of this question. The question is, fish population in a lake after t months is given by p of t equals to 1000 divided by 1 plus 3 e to the power of minus 0.5 t. Part 1 was find the initial population, and we found that at t equals to 0, if I substitute 0 here, I get e to the power of minus 0. So it is 1 plus 3 in the denominator. So we found that p of 0 is indeed equals to 1000 divided by 1 plus 3, and that came out to be 250, right? Quarter of 1000. So the fish population to start with is 250. That was part A. You can always look into the link for the details of this solution. Part B here is, when will the population be 75% of its capacity? Now that is very interesting. First part is to find the capacity itself. Now, what do you understand by the capacity from this equation? Well, the idea is capacity is maximum, right? That is what it is. If you look at this particular function, what maximum value can it take? Now, we are dividing 1000 by something, right? So, maximum could be if that something is just 1 and not a number more than 1, because it is 1 plus something, right? So that gives you an idea. It could be 1000. So how do we find that? So one way to find the capacity is we can find the limit of this population as t approaches a large number. Let's call t as infinity, right? So if you calculate that, we get 1000 divided by 1 plus. Now e to the power of minus, you could write like this, 3 over e to the power of instead of minus, now it becomes plus, right? So we'll not write minus, we'll write half, or 0.5 t. Do you see that? So let me make this positive. Okay. Now if t is very large, then e to the power of that t is going to be extremely large, and 3 divided by a large number is going to be 0, right? So this limit will be 1000 divided by 1 plus 0, so that means 1000. Do you understand? So we know that the maximum capacity is 1000, right? So that is first thing which we need to understand. Now let's go through the question once again. When will the population be 75% of its capacity? So what is 75%? So 75% of capacity we found was 1000, which is 1000, is equal to 75% means 75 over 100 times 1000, right? Which is 750, right? So 750. So that is the number. When will the fish population be 750? That is what you need to find. Now, solution of this question helps you to understand how to solve equations involving E. So P of t is 750 for us. We'll write 750 equals to, then the equation, which is 1000, divided by 1 plus 3 e to the power of minus 0.5 t. Okay. So to find the answer, we'll just cross multiply. That is my first step. So 1 plus 3, general steps, right? Minus 0.5 t equals to 1000 divided by 750, right? So that is what it is. Or you could also write dividing by 3 as 4 over 3, right? Whenever 3 is involved, we normally don't write in decimals. Okay. And further, we can take away 1. So we have 3 e to the power of minus 0.5 t equals to 4 over 3 minus 1. So that means 4 over 3 minus 1. 4 minus 3 is 1. So we get 1/3. Dividing by 3, what we get? So let me take this to the right side and solve it further. Okay. So what we get here is e to the power of minus 0.5 t is equals to 1 over 3 times, we'll divide this by 3, or it's just 1 over 9, right? So what we have here is, let me use another ink also. Okay, so we have e to the power of minus 0.5t equals to 1 over 9. To solve this equation, we can take log to the base e, right? So for any exponential equation, normally we take log, but whenever e is involved, log to the base e is a good option. So basically, we'll take log to the base e of e to the power of minus 0.5t equals to ln 1 over 9, correct? Now these are inverse of one another, and therefore what we get here is minus 0.5t equals to ln 1 over 9, correct? Now clearly t is equal to minus of ln, I'm writing limits, ln divided by, 1 over 9 divided by 0.5, right? So that is how we can get the value of t. So let's use calculator. So we have function ln here within brackets 1 divided by 9, bracket close, divided by 0.5, right? We'll multiply by minus this number. So it is a negative number as expected, and when you multiply by minus, what do you get? So from here clearly we get this value as equals to 4.39, correct? So that is the answer for this particular thing, correct? So that is how you could actually solve such questions whenever you're working with exponential functions with base e. Ln is a good way to solve. Take log to the base e on both the sides and then solve, right? That's the answer. So for us the answer is it will take slightly more than 3 months, or you can say 4.4 months, right? That is how you will be solving this question. So move on to see the solution for parts C and D, where now we will discuss derivatives of exponential functions. I hope these two parts help you to recapture all what you learned about exponential functions and solving such equations. Thank you and all the best.